Welcome to our database house party, number 2. And what an exciting time. We're going to talk about data-driven apps. And to kick us off is Maria Colgan. And I don't think she needs any introduction, but Maria is our master product manager at Oracle. And she's definitely one of our biggest evangelists for the Oracle database. And Maria has been around with Oracle since version 7.3, which is fantastic. And she was definitely a product manager for the database in memory and the query optimizer. I think we always know, Maria, that whenever it comes to optimizing SQL, you're the girl, so or the woman. So with that, I'd like to turn it over to Maria to kick us off. Good morning.
Good morning, Tammy. Thanks so much for having me. And in this morning's session, what I'm going to do is I'm going to talk a little bit about how we believe at Oracle the future is data-driven. And I'll explain what we mean by that and how you're going to be able to become a data-driven organization. And what this will do is set up a foundation for the rest of the sessions that we'll have as part of the house party today, and hopefully give you a lot of insight in how you can not only use data-driven apps with an Oracle database, but also develop them with Oracle. So let's just jump in and get started. And you know, today businesses, they're in a very competitive situation. And in order to keep that competitive edge, they need to fully understand their customer needs and be able to deliver value to that customer. And so the way they do that is by utilizing data-driven apps. And those apps are often developed using new or modern development paradigms. And so, as I said, I'm going to focus today on both of those, data-driven applications and how they're developed. Now, when we talk about a data-driven app, what do we mean by that? What is it? Well, they're applications that are going to utilize lots of different types of data. So there'll be stuff like spatial data, as well as the standard relational data, documents, maybe JSON, XML. There may even be streaming data from IoT style workloads. There'll also perhaps be graph, property graphs, or even some more secure environments, things like blockchain. And so they're going to access a very diverse set of data types, and they're going to, in order to get value out of them, actually use that data in a very different way to a traditional online application. So they're going to do things like use machine learning to do fraud detection, or to do recommendations on, you know, in real time recommendations to customers for alternative products that they might want to buy. They're going to do things like use Spatial to track products as they're being shipped to customers, and use social graphs to find the right influencer in a community to be able to target with their marketing so that they can actually have a bigger impact with that marketing campaign. So as I said, they're going to use data from a lot more sources than we would traditionally use, and they're going to use that data in different ways in order to be able to create this value that the business can then use to improve their decision making and improve the way they run their business. Now, as I said, these data-driven applications are built using a lot of the more modern paradigms, dev paradigms that we have. So for example, they typically have a microservice architecture. They'll perhaps do event processing in order to be able to share information among the services. They are often built, because they're going to predominantly be web-based applications, as SaaS apps or software as a service. And so they'll need to deal with a multi-tenant environment, making sure that they have security in depth across the platform in order to be able to support that multi-tenant environment. And of course, nothing is able to come down for large periods of time. So we're going to have to do our development in using CI/CD, or this continuous development and deployment of new features and functionality, all while the application continues to run. That's basically the environment we're in today. And it's what we're going to focus this session on, as well as the rest of the sessions in today's house party. So That's great. We now know that we've got data-driven apps, and we know that we're going to use different development paradigms in order to build and deliver those applications. But before we get into it, I want to just take a moment to acknowledge the fact that because we are using different types of data that we may not have used before, and we're going to be using that data in different ways, there is the potential that we're going to have to use more complex or new products as part of that deployment. And some of the development decisions or the development paradigms that we may want to use, although they're going to simplify and accelerate our development process, they can potentially complicate our actual management and deployment of those applications into production. And if we do go down the road of using a different specialized database for each of the different types of data that we've got, or for each of the different use cases that we've got, we open ourselves up for potential fragmentation of our data or creating data silos, which is a massive problem because we won't be able to get a clear view of perhaps our customer or perhaps our business problems. And of course, the volume of data that we're working on these days is far greater than it's ever been before. And that too can add to the complexity of having to manage multiple databases with multiple different types of data and use cases. So Oracle wants to simplify all of that for you. We want to make it really, really easy for you to be able to utilize and build data-driven applications. And we've done that by integrating support for all of these new data types and these different use cases into the core database. So instead of having to use a different tool for cloud service for each of your different data types and your different use cases, we want you to use a converged database, one that's got support for all of these different types of data and use cases, but also has a synergistic relationship with those development paradigms. And by that, what I mean is that Oracle has put in place features and functionality inside the database that helps you use those development paradigms without adding the complexity that would normally come with them to your environment. So we want to create that synergy between your data and your development paradigms in order to make it very, very easy for you not only to build, but then to use these applications. And so for the rest of the session, what I want to do is show you how Oracle allows you to do that. Allows you first to create value from data in new ways. So we'll talk about all the different data types that you may want to use and how we can quickly create value with those. And then for the second half, we'll move on and we'll look at the modern development paradigms and what are the best ways to implement those with Oracle in order to be able for you to quickly create these types of applications. So I think the first thing when people talk about modern apps and data-driven applications, machine learning seems to be on the tip of everybody's tongue. It seems to be the thing that everybody wants. And Oracle makes it incredibly easy for you to be able to take advantage of machine learning to do all of those really cool things with it. Things like being able to make real-time recommendations based on a customer's behavior, to do fraud detection, but also to do things like sentiment analysis, understand what your community of users are feeling right now and what is the best way to help them or complete or fulfill that need that they may have. And the reason Oracle makes it super easy is that we've actually had machine learning built into the core database since Oracle 9i. Tammy let you into my secret that I've been around Oracle for quite some time earlier, and it's true. I've been able to use machine learning inside in the Oracle database now for well over 20 years, and there's more than 30 of these machine learning algorithms built into the Oracle database. Now, if you're not a data scientist and you're thinking, I'm not going to be ever able to use machine learning, let me assure you, if I can do it, you can definitely do it. It's super easy to use. You can do it all through SQL. I'll show you an example in just a second. But if you're not feeling confident to understand, well, which machine learning algorithm should I be using? How do I know the difference, the different algorithms for recommendation versus fraud detection, etc. Don't panic. Starting in database 12c, we've actually introduced something called AutoML, where it's super easy for you to be able to take advantage of it. You simply tell us what data set you want to look at, what kind of question you're after, and we'll automatically determine the right algorithm to use. We'll build the model automatically for you, and then we'll test it, refine it, and then allow you to be able to use it in your application. So the other thing I wanted to mention just before we move on to the example is the fact that machine learning is free inside of the Oracle database. It used to be a charged or additionally licensed option. That's no longer the case. So if your reluctance to use machine learning with the Oracle database might have been because it was an extra cost option, don't let that deter you now. As I said, it's super easy to use. I'm using a simple two-step approach. The first part of what I need to do is build my machine learning model. And so I do that by taking advantage of our DBMS data mining package. I give it a name. I say that I'm looking to classify or do a classification model here, because I'm looking to predict which of our customers would perhaps respond to a steak dinner special that we would be offering at our restaurant. I will build that model on historical data. In other words, I look at my past customers' details, see who did buy these dinners, what kind of person would respond to this type of dinner, and then I can simply use SQL to deploy that model against my existing data set, so I know which customers to target with that particular promotion for perhaps a steak dinner. Now, one of the other things we really need to focus on when we're becoming data-driven is we need to be able to run analytical style queries, not just transaction processing in real time. And Oracle makes that incredibly easy by offering you our database in memory capabilities, where data can be brought into memory in both a row and a column format simultaneously. So transaction processing goes to the row format, which is best for that, while our analytical style queries can use our in-memory columnar format. And that really can accelerate the performance of those analytical style queries, because it gives us a couple of advantages. It allows us to access only the columns we need for those analytical queries. The data is in a very processing friendly format. It's compressed. We're able to use SIMD vector processing on that compressed format and really accelerate analytical queries. But what's nice about this, I'm not going to show you an example of using it because it looks just like a regular SQL statement. No changes to the application code are needed in order to take advantage of database in memory. Once you allocate the in-memory column store and begin to populate it with data, that's it. You don't need to make any changes to your application code. It is really, really easy to add real-time analytics either within a transaction or in parallel to your transaction system on that latest set of data that you may have. So very, very powerful technology. Now, I mentioned earlier on that we are getting data in our data-driven apps from a whole host of new resources and sources, and also perhaps in real time. Perhaps the data is being streamed into our database. And we want to make sure that we're able to ingest that data and get value from it instantaneously. And Oracle makes it incredibly easy for you to analyze IoT streaming data by allowing you to very quickly insert that data directly into memory and then instantly return control back to the application. So you no longer have to wait for those inserts to be propagated to disk and have that acknowledged before the application can move on. And by allowing you to kind of just bulk load data into memory and begin to then start processing it, it really accelerates and improves the performance of this ingest. And so I want to give you a quick example of how you do this, because things do change a little bit. First, you're going to create the table and you're going to give it an extra attribute that you wouldn't have had before. You want to tell Oracle, hey, when I write into this data, I want you to use these in-memory buffers and optimize that write or that ingest for me. And then the only change to my code I need to make is, as part of my insert into my table, I need to give a mem optimized write hint. So that tells the Oracle SQL execution engine, hey, don't treat this data as a standard insert. I want you to use this fast ingest method. And as soon as I start ingesting my IoT style or streaming data, I can then start to begin time series analytics on it. Because why? Oracle has all of those analytics built into the database for you. And I can use simple SQL statements in order to be able to do that processing. One of my favorites is the lag capability. So what it allows me to do is to compare the current reading that I've got, my current sensor reading for this hour, to last hour's sensor reading, to make sure and check what the difference is. Because oftentimes we're not really interested in the individual IoT entries. What we're actually interested in is the difference between those entries. Am I seeing a large fluctuation in perhaps the temperature of my goods that I'm shipping, or perhaps in my electricity meter or my water meter? Is there a massive difference which would indicate a perhaps water leak in my home? One of the other great things that people are using today in these data-driven applications, of course, is graph analytics. And it's amazing what you can do with this. It allows you to do all sorts of things. I mean, I think the most common one that most of us think about is that being able to find that influencer on social media, to be able to find the right person to target. But it also allows us to do a whole bunch of things. It allows us to build a community and to rank our different members, as well as to get a very complete view of a customer, which is really, really nice. And Oracle has over 50 in-memory parallel analytic graph functions inside in the Oracle database. We also actually have a SQL-like query language that you can use to do your graph analytics. And again, because it looks so like SQL, it's very, very easy for you to adopt. And just like with database in memory, sorry, not just database in memory, but with our machine learning, graph used to be a previously charged additional option for the Oracle database, and that's no longer the case. It's now free in all editions, so you too can be able to take advantage of the sophisticated graph analytic algorithms that are built into the Oracle database. Everything from doing that influencer, or salsa as what they call it, prediction. So being able to figure out who to follow, or who are the influencers, who are the folks we should target perhaps with our marketing campaigns for our data, for our business, for our service, so that they will influence others to also use our service. So lots of amazing stuff there. Now, one of the newest data types that people love to use and will be using as part of today's sessions, of course, is JSON documents. Being able to really simplify the data model by storing the information as JSON documents so that they can rapidly evolve without breaking, of course, the data model stored inside in the database. And Oracle has native support for JSON and, of course, XML, its predecessor, inside in the Oracle database. So we can effectively utilize a JSON document just like any other data in the database. I'll show you an example of that right now. But you can also index it. It can be used as part of materialized views. And of course, because it's built into the Oracle database, they will, of course, support all of the ACID transaction capabilities that you know and love from the Oracle database, even when you're operating on JSON documents. And they can be accessed in parallel. They can be stored in the in-memory column store so that you can do faster analytics on it, making the use of JSON super, super easy with the Oracle database. Here's a quick example. I've created a table called restaurant. Simple 2-column table. It's got the restaurant name, and then the menu for that restaurant I'm just going to store as a JSON document. So that's going to allow me to very quickly iterate that menu without having to do massive updates all over the database. And what's really great about Oracle is I can tell the database, by the way, this is JSON data, that I'm putting in here, and I can create a constraint that will actually check that I am inserting legitimate JSON documents so that they've got the right the right format as they're being ingested. That'll give me a clue that everything is going well. And then I'm able to access the different elements within that JSON document using a very simple dot notation, the same way we would use to access an individual column in a table. I can use that same approach to access and look at elements inside of my JSON document. So for example, in my query here, I'm totting up the total for a particular order. And so I need to get things like the menu name, which is inside the menu JSON document. I need to pull out the name element. I'm able to do that by referencing the table name, the column name that has the JSON document, and then whichever element inside that JSON document that I want. And in JSON documents where we've got collections or arrays inside of the JSON document, that dot notation will allow you to walk through the different elements to get to the piece of information that you want. So you can continue to use that, and it can not only be used as part of the select clause, you can join on these elements from the JSON document, group by, order by, whatever you need to do with them. So effectively, once it's inside the database, it's going to look and feel exactly the same as any other data. But of course, giving you that flexibility in the schema. Now, spatial data is also incredibly important because an awful lot of us are remote these days, and we need to understand distance between objects or places. And we also, of course, want to analyze things like networks, whether that's transportation networks or telecommunication networks, or even understand our sales territories. And again, Oracle has hundreds of in-database spatial operations and function that you can use. And again, used to be a paid option, no longer the case. It's now free for anybody to be able to take advantage of the spatial capabilities inside of Oracle. And I've got a quick example here to show you what that would be like. So say, for example, we had a slightly different restaurant table. This restaurant table, all I've got is the restaurant ID, its name, and its longitude and its latitude. By taking advantage of the built-in SDO geometric functions that we've got, I'm able to very quickly determine what other restaurants are around my restaurant, so that maybe I could make recommendations in my application. If somebody is this is a very favorite restaurant of theirs, what other restaurants in the neighborhood that would be, say, less than 5 kilometers from that restaurant should I recommend for them to also check out? And again, I can do it in very, very simple SQL statements. So give me the names of the restaurants and their IDs where the restaurant is within a distance. So in my case, I chose 5 kilometers of our restaurant, Bad Bob's. So it's super, super easy for you to be able to use this because, as I said, all of this functionality is built into the Oracle database. Now, along with machine learning, one of the other big or hot items at the moment tends to be blockchain. The ability to be able to ingest data or store data and prevent fraud from taking place in that, or prevent somebody from being able to change that data and effectively cover up their fraudulent activities. And with Oracle Database 20C, Oracle is introducing new blockchain tables. These are tables that are like an immutable ledger, because when you can insert data into them, but when you insert that data in, there's a hidden column in there that cryptographically chains the rows to each other. So there's no way for you to be able to tamper with that data. And if you did tamper it, then you would break that chain and we'd be able to know that somebody had tried to do something that wasn't kosher with this data. So there's no updates or deletes allowed on this table through the user. But even if they were trying to manipulate the data on disk in the data blocks, that would be triggered because they would break that cryptographic chain. And so even though it looks exactly the same as a standard table, the only difference is when I create the table, I say create blockchain table, After that, it looks and feels exactly the same as a regular table. So I can query it, I can insert into it, just all the standard things I would do with my application. The only difference is I can't update it and I can't delete from it using the standard delete commands. That way, it's going to keep track of everything I'm doing in a very, very secure way. And again, free inside the Oracle Database 20C. So now we understand that Oracle can definitely store all of these different data types and we can easily and quickly get value from them. That's great, but what about how I'm going to develop my data-driven application? Because after all, it is going to use these modern paradigms. I want to be able to use microservices. And you know, Oracle, when I think about an Oracle database, I'm thinking more monolithic style applications, and that's old school. I don't want to get involved with that. And the good news is, regardless of the development paradigm you want to use, Oracle has built in, as I said, natively integrated features and functionality into the Oracle database to offer you what we call data development synergy or data dev synergy. In other words, we've got functionality inside the database to help support each of these development paradigms that you may want to use. And what I want to do now, just before I wrap up my session, is share with you how you would use some of those features and functionality inside the Oracle database to support these new development paradigms. So let's start with the most obvious one, and the one I think everybody is familiar with is the fact that we don't want to build monolithic applications anymore. We want to take advantage of microservices where each of the core aspects of our business is treated as a separate service. And by treating it as a separate service, we're able to give our developers a little bit more independence and agility because they're no longer tied to the other teams inside in the either the app development or inside the business. You know, there's no coordinating, taking the system down, etc. And so because it gives us that agility and that independence, we're able to more rapidly develop and innovate for our business. Now, traditionally, that would mean creating a separate database for each of those microservices, typically a database that was specific to that particular data set or use case. But with the Oracle database, we want to offer you that same flexibility, that same independence, but in a much easier to manage environment. Instead of having hundreds of different databases and having your ops team or even your DevOps team having to understand how to manage, monitor, and secure all of those different databases, we're going to offer you a single database, but still with that independence. And we're able to do that by taking advantage of our multi-tenant architecture, where each microservice can be a different pluggable database, either in the same physical container database or in a small number of those container databases. So allowing you to have that isolation and independence that you need, but making it much, much easier for your ops teams to be able to manage because they're all using the same underlying database. And with our multi-tenant architecture, we can manage many of these databases as one. So making it much, much easier to build a microservices type architecture. Now, for a lot of developers, they're going to listen to the beginning of this presentation and they're going to say, oh no, she wants me to really learn SQL and PL SQL and understand all of this stuff. That's not how I want to operate. I just want to use my data store as a Bitbucket. I just want to make a REST call from my application code out to a database and just get the data I need back in the format I need it. I want it as a JSON document or a .csv file, whatever it may be. I just want to get it back in that way. And that's no problem. Oracle understands that developers need this more API-driven approach and to be able to make a REST API call into the database and get whatever data they need. And with Oracle REST Data Services, or ORS, that's exactly what we allow you to do. We can automatically generate REST endpoints for any SQL or any stored procedure inside in the Oracle database, allowing your developers to get access to that data by making a very, very simple API call. Now, event-based processing is another huge area in modern app dev at the moment, and Kafka is probably the environment or the platform that you think of when you think about event-based processing. And Oracle understands that, and we have done a huge effort to integrate with Kafka. So we have our Golden Gate technology, which can replicate and stream database changes into Kafka so that those events can be tracked and utilized. But we also have a new query event for Kafka inside in the Oracle database. Because remember, queuing and event processing is not new to the Oracle database. We've actually had our advanced queuing technology inside the Oracle database for decades now. And of course, it provides all of the ACID transactions and powerful SQL capabilities that the Oracle database offers for event processing. And in 20C, we have introduced OKafka is what we call it, which enables apps to use the Kafka API to transparently operate on our database queues. So if your application is currently using Kafka, or your developers, that's what the APIs they know. They don't know anything about Oracle Advanced Queuing, that's no problem. They'll be able to access the Oracle Advanced Queuing using those APIs starting in 20C. So there's nothing to learn in order to take advantage of database queuing as part of that. Now, these data-driven apps, as I said, they're typically online applications, and oftentimes can be a multi-tenanted environment because it's going to be a SaaS offering. We'll actually have multiple customers trying to use our service, and we want to make sure that those customers are completely isolated from one another, but still have all the same features and functionality. And the easiest way to do that is not complicate the application code by having to do all of the tenant management there, but actually take advantage of Oracle's multi-tenant architecture. Each of your customers or tenants is in their own separate pluggable database. They all have the same schema, look and feel, making the application code super simple, but you get the isolation that you need for each tenant. And you also get ease of management because we can manage many of these tenants as one, making it very, very easy to implement a software as a service. Now, because these are online applications typically, and because businesses are now 24/7, especially since we're all at home these days, you know, there's no business hours anymore. People are working and shopping and doing business all hours of the day. And so we want to make sure that our application remains open for business. We don't want to take massive downtimes in order to be able to offer new features, functionality to our applications or to our users. And Oracle makes it incredibly easy to perform this kind of continuous delivery of application enhancements because we have basically architectured support for full online schema evolution. So all of the kind of changes that you would make to a schema, whether it's adding columns to a table, rebuilding indexes, partitioning a table that once was small, that's become very large, all of those operations can happen fully online. In other words, users can continue to access not just query, but also DML operations on those objects as they're being changed. And of course, we also have our addition-based redefinition capabilities, which allow you to not only just change the format of or the structure of the data inside in your database, but also your PL SQL packages, and allows you to offer different different versions of your application code inside of the database as you evolve it, making sure that the application always remains online and open for business while you're actually deploying those new changes. Now, we also understand that with these modern applications, we are looking to typically deploy these on a global scale, and that often requires us to have a distributed data architecture, especially with data sovereignty rules now, where countries don't want their data set to be stored in other places. And so Oracle is able to support that by taking advantage of our sharding capabilities, which allows you to break up a very large database into a farm of much smaller databases, each of them able to operate independent of one another on their own hardware. So if for some reason we were to lose one of the shards, the rest of the shards remain open for business. And the only disadvantage we've got is that we don't have access to the data potentially on that shard. But because this sharding is implemented as an Oracle database, all of the high availability and disaster recovery features we've got in the Oracle database will happily work on your shard. So even if one was to go down, we could fail over to a standby for that shard and continue to stay open for business. And because it's built into the Oracle database, again, all of the features and functionality of the Oracle database will work with that. Now, for a lot of businesses, it's not always a large development organization that's building these apps. Oftentimes, we've got some very sophisticated business users that are tech savvy that actually want to build their own applications to help themselves. And Oracle is fully aware of that. And we make it super easy to create what we call low-code applications by taking advantage of our Apex or low-code development environment that's integrated into the Oracle database. And because of this tight integration, it's really, really easy to get started. You can load data from a spreadsheet. You can do it from a table inside in a database if you want, and begin to instantly build your application. We've got templates there, so you can drag and drop to kind of get the look and feel of the UI that you want. And of course, because it's built into the Oracle database and it's browser-based, you don't need to install any additional software to be able to get started. And we take care of doing all of the connectivity and the security of that application for you as part of the database. And so it's super, super easy to both get started, but to continuously iterate or change and adapt that application. Now, speaking of applications, for the rest of the event, we're going to be looking at something called GrubDash app. And I'd like to hand over now to Sanjay, who's going to actually give you a little bit more detail about the architectures that we're going to be using. So,
I'm sorry.
No, I was just going to say, so Sanjay, I'm going to stop sharing and hand it over to you.
Okay, thank you, Maria. I hope you can hear me. So Maria talked a lot about the converged database and the capabilities in it. And we also talked about microservices. So of course, the trend is towards building data-driven applications. And there's also, developers want to build microservices. So the data-driven microservices is the topic here. And I have the pleasure to introduce, the architecture and the various other talks that follow this session here. I'm relatively a newbie at Oracle, about two plus years, but have been building systems in big data, AI at Sun, Intel, and Autonomy, and kind of bringing the app and systems platform to the database and kind of connecting the two. So if you look at what developers want to build, again, I think it's clear from Maria's talk that data-driven applications as microservices, but there are also complexity, right? Microservices can become complex very quickly, but can be simplified, as you saw in some of the areas Maria talked about around coding, around DevOps, around performance, availability, security. Again, with the right persistence layer, right? So again, we're talking about connecting the app development platform to the database, to the persistence layer that microservices can use. And, on the right here, you see a lot of the technology that's now gone into the converged database. Maria talked about in-memory analytics, you talked about JSON, blockchain, events, machine learning, spatial. But there's even more. There's some graph capabilities. There is, the multi-tenant capacity. There are transactions. People can support XA, sagas in microservices. So again, there's a lot of capability there. But we also want to tie it to the app platform. How do you build out, with the modern open interfaces? So again, the keyword here is simplicity, but also the idea of open interfaces, then connected at cloud scale. Now, a lot of these technologies are available on the Oracle Cloud, Gen 2, what we call the Oracle Cloud Infrastructure. But a lot of them are also available in our on-premise database offerings. So maybe quickly, before we jump into the architecture and I introduce the rest of the talks, let's maybe understand what a microservice is, right? So we talk about loose coupling. Uh, Again, we built service-oriented architectures all our lives in some ways with what we call monoliths. They were service-oriented. If you built a WebLogic architecture, except that, there were a lot of data dependencies. So microservices come back and say, there is loose coupling of these various services that come in to build an application. So if every service has to be updated at the same time, it's not loosely coupled, right? So this whole agility that comes into building applications comes with microservices. The other piece that I like about it is this concept of bounded context, right? So if you know too much about your surrounding services, you don't have a bounded context. So these two aspects of loose coupling and bounded context give you the ability to contain a microservice and then bundle a bunch of these together. And then that's what we're going to talk about in the architecture as we go along. So, we talked a lot about simplicity, right? So where does the complexity come from, right? The complexity comes from a lot of this information, this data driven, right? Again, people produce data through web servers, through orders, through mobile, through IoT, through transactions, right? So a lot of these then start flowing through a Kafka pipe into various other data sets, right? So there's a lot of data movement, many technologies, multiple data stores, and what we call copy contagion, where data is copied many times that has issues with backup, recovery, availability, security, again, becomes complex and difficult to maintain. And this is where I believe a lot of people come back and say, oh, I don't want to do microservices. They're very complex. I would rather kind of do macro services, or I would kind of, just kind of do what I'm doing. So what we believe is that we can improve this, right? And improve this by offering the simplicity through the converged database. And you can start thinking about the event streaming, cloud scale, the managed service that the autonomous database provides. So what the talks after this will cover is the microservices support across the various data types that are supported, the open interfaces, with building blocks and APIs, and with less to learn, manage, mainly because your skill sets that you have with SQL, with Java, with some of the other modern programming languages that you use can be brought to bear in this architecture, right? So Mari talked about GrubDash. So GrubDash is basically, a hypothetical application here, but it's not, something unfamiliar. It's like, if you use Uber Eats or DoorDash, it kind of, you have a consumer that searches for recommendations, orders something from a restaurant looks at the order, looks at its inventory, and then gets it ready to get delivered, right? So in this flow, you will see that, of course, there's a lot of AI ML to be built around it, but at the crux of it is the transactional capability, the ability of streaming orders into an order service, the ability of an order and inventory to be transactional, so that you don't ship the order twice, or you have exactly once delivery. And of course, there's elements of spatial data, text data in this. So without further ado, let me introduce the architecture, which is again an app tier that looks at the database tier here, right? So one of the talks here will introduce the entire architecture. So the first talk will be around how do you design a microservices-based architecture. So Kwasi and Paul will take you through the design of it. There are also hands-on labs that you can get your hands on to. There's a link here, it will be shared after this session. So mainly, you can then search these reviews. So the ability to use Oracle text to search through recommendations before you order something. So for example, if you were to order your favorite sushi from a sushi restaurant, how would you search through those reviews, place an order? So the second talk will cover the capabilities of Oracle text and JSON to be able to do that. And then there's also the delivery aspect, right? So once you kind of deliver these, there's the route mapping. A talk on maps and spatial analysis will cover the capabilities of the database in terms of how do you do a single route, how do you optimize through multiple routes. And then there's another talk on modern application development, right? So how do you do cloud native development? How do you develop in Python and JSON and Java, not only just SQL, right? So you can start to do modern application development on the cloud. And then finally, talk about how do you kind of bring these things together in terms of UI development, right? So UI development can be low code. Maria talked about Apex. We talk about, we show you some ops analytics being built, how easy it is for you once this data starts to come in of orders, of inventories, of delivery, how to kind of get an ops dashboard going. There's also, some aspects of JavaScript of putting together UI fairly quickly in this. So you can basically see how the flow goes. And of course, there are concepts of availability domains and fault domains and other things that can come in to make an application like this, very, very data driven, highly available, highly performant, and highly agile in some ways. So that's, I think, the architecture. And stay tuned for the other talks here. The next one, I believe, is going to be a talk by Paul, Kwasi, and Martin, where they will talk about this application and also give examples of how they've used the various capabilities in the database.